Hello students, in previous lecture we have studied about the different types of operations takes place on the surds, that is addition, subtraction, multiplication and division of surds. Then the examples which is based on those concepts which we have already solved from practice set 2.3. Then one more concept which is related with the surd, that is rationalizing the denominator. See here, rationalization of surds. Then taking few examples from practice set 2.3, I am going to discuss with you about that. First of all, see here, rationalization of surd we can takes place when we find the rationalizing factor of the given surd. Then first of all we have to find out the rationalizing factor of given surds. Then see here, for example, root 2 is an example of surd. Then the rationalizing factor of that root 2 we have to find out. Then see here, when the product of two surds is a rational number, then each surd is a rationalizing factor of each other. That means, see here, the surd root 2 is given here. If we multiply by root 2 to this root 2 to this surd, then we get root 4. That means root 2 into root 2, root 4. And we get the value of root 4, that is 2. That means when we multiply by root 2 to this surd, we get the rational number. 2 is a rational number. Therefore, here root 2 is a rationalizing factor. Rationalizing factor of root 2. That means those are rationalizing factors of each other. That means if product means multiplication of those two surds, if it is a rational number, then see here, root 2 if it is multiplied by root 3, then we get root 2 into root 3, that is 3 into 2 6, that is root 6. But root 6 is, it is not the rational number. It is not a rational number. Therefore, root 3 is not a rationalizing factor. Rationalizing factor of root 2. That means when product of two surds is a rational number, then those are the rationalizing factor of each other. And few more examples I am going to discuss with you. That is here, root 2 into root 8, then we get root 16, that means we get 4, that is rational number. Therefore, root 8 is also rationalizing factor of root 2. That means every surd has many rationalizing factors. It may be one or more rationalizing factors. Similarly, if root 2 is multiplied by 2 root 2, then we get, see here, 2 into root 2 into root 2. We have to multiply and find the product of this, that is 2 into root 4. Therefore, we get 2 into 2. Therefore, we get 4, that is rational number. Therefore, 2 root 2 is also rationalizing factor of root 2. Similarly, we can find out the few more rationalizing factor, that is 3 root 2, 7 root 2, or 5 root 8, 7 root 8 are also rationalizing factors. Rationalizing factors of root 2. Factors of root 2. Then those are the few examples of getting rationalizing factors of given surds. Similarly, we can get the rationalizing factor of root 3 also. Root 3, if it is multiplied by root 3, then we get root 9, that is 3, that is rational number. Therefore, root 3 is a rationalizing factor. Rationalizing factor of root 3. Similarly, root 3 is multiplied by root 27, then we get root 81, that is 9. 9 is also rational number. Therefore, 27, root 27 is also rationalizing factor of root 3, as well as 2 root 3, 5 root 3, 2 root 27, 5 root 27, 9 root 27 are the few rationalizing factors of root 3. Then that is about the rationalizing factors of surd, and those rationalizing factors are useful to rationalize the denominator of given surd. Then we have to solve few examples from practice set 2.3, that is in question number 8. Few examples are given there, that is practice set 2.3. Then last example which is given here, that is rationalize the following. Rationalize the denominator of following given surds. Then one of the example which is given here, that is 3 upon root 5. See here, in this example it is an example of surd in which denominator is root 5. Then we have to convert that root 5 into rational number without changing the value. Then see here, it is an example of ratio, that is 3 is to root 5. Here 3 is to root 5. Then we have to use the properties of equal ratio. Then we can convert this into another type of ratio of which denominator is rational number. For rationalizing the denominator, we have to use the rationalizing factor of that surd. Then see here, denominator, we have to rationalize the denominator only, not the numerator. And here denominator is root 5. Then root 5 is also rationalizing factor of root 5. Therefore, we have to multiply numerator by root 5 as well as denominator by root 5. See here, 3 into root 5 upon root 5 into root 5. Here we multiplied by root 5 as well as denominator is also multiplied by root 5. Therefore, value of this ratio does not changes. Value of that surd does not changes. Therefore, we get, see here, 3 root 5 upon root 5 into root 5, root 25. Then we get 3 root 5 upon root 25, that is 5. See here, in this example, denominator is 5, which is a rational number. That means rationalization of the denominator of that given surd. That means here 3 upon root 5 is equals to 3 root 5 upon 5. That means those are the equal ratios. Then the same concept which is used to solve the more examples from that practice set. Then 5 upon root 7. Then see here, the root 7 is a irrational number. That is, in this surd, we have to rationalize the denominator. Therefore, rationalizing factor of root 7 is root 7. Therefore, we have to multiply numerator as well as denominator by root 7. Therefore, 5 into root 7 upon root 7 into root 7. That is 5 root 7 upon root 7 into root 7. That is root 49. Therefore, 5 root 7 upon 7. See here, the denominator is now becomes rational number. That is about the rationalization of surd or rationalize the denominator of given surd. One more example, that is 5 upon 2 root 27. Then see here, in the denominator 2 root 27 is there. 27, the rationalizing factor of 27 is root 3. Then we have to multiply numerator by root 3 as well as the denominator by root 3 also. Then we get, see here, 5 root 3 upon 2 into root 81. Then we get 5 root 3 upon 2 into root 81, that is 9. Therefore, here 5 root 3 upon 9 into 2, 18. See here, 18 is a rational number. That means 5 upon 2 root 27 is the 5 root 3 upon 18. Here, in this surd, 18 is a denominator which is a rational number. That is about the rationalizing the denominator of given surd from practice set 2.3. Then one more new concept which is related with the surd, that is binomial expressions or binomial quadratic surds. Then taking few examples of those surds, then you will determine the binomial quadratic surds. Then see here, few surds are given like this. Root 3 plus root 2, it is a binomial quadratic surd. Binomial quadratic surd. See here, in this two terms are there, like binomials. In the of examples of polynomials, there are two terms like that. Here two terms are there, root 3 plus root 2, and between two terms plus or minus sign should be there. Then root 3 into root 2 is not a binomial surd. It is not a binomial surd. If there is plus or minus sign between two terms of quadratic surd, then it is a binomial quadratic surd. It is a quadratic surd because the degree of both surd is 2. That means degree of when surd is 2, then it is a quadratic surd. And there are two terms, therefore it is a binomial. And degree is 2, therefore it is a binomial quadratic surd. Then see here, few more examples of binomial quadratic surd is root 5 minus root 7 is also example of binomial quadratic surds, as well as root 7 minus 5 is also binomial surd, example of binomial surd. Then 3 root 5 plus 7 upon 2 is also binomial quadratic surd. Then root 2 root 7 plus 5 root 3 are also few examples of binomial surds. 7 upon 5 minus root 2 is also example of binomial quadratic surd. See here, these are the few examples of binomial quadratic surds. Then one more concept I am going to discuss with you, that is conjugate pair of that binomial quadratic surds. See here, conjugate pair of binomial quadratic surd. See here, taking one of the example, that is all of you have studied that a plus b in bracket, a minus b another bracket, then we get the expansion of that is a square minus b square, like that. See here, one of the binomial surd, that is root 3 plus root 2, if here taken, then if that binomial quadratic surd is multiplied by another binomial quadratic surd, that is root 3 minus root 2, then we get, see here, it is like the a plus b into a minus b. Therefore, we get root 3 square minus root 2 square. Then see here, root 3 square, that is 3, because here nth root of a raised to n is n, a. That rule is useful here. Then square root of 3 square is 3. Like that, square root of 2 square is 2. Therefore, we get here 1. Similarly, one more example I am taking here, that is here root 7 minus 5 upon 2. Then we have to multiply it by root 7 plus 5 upon 2. Then a minus b, a plus b, we get like this, that root 7 square minus 5 upon 2 bracket square. Therefore, we get here square root of 7 square is 7, and 7 means 7 upon 1 minus 5 upon 2 square, that is 25, 5 square upon 2 square, that is 4. Therefore, we get here 7 upon 1 minus 25 upon 4. Therefore, we getting here, that is 7 into 4 cross multiplication, that is 28 minus 25 into 1 25 upon 4 into 1 4. Therefore, here 28 minus 25, that is 3 upon 4. Then focus here, root 3 plus root 2 and root 3 minus root 2, when those surds are multiplied to get the product, and here the product of those two surds, we get here rational number. Therefore, root 3 minus root 2 is a rationalizing factor of root 3 plus root 2, as well as root 3 plus root 2 is a rationalizing factor of root 3 minus root 2. That means those are the conjugate pairs of each other. Similarly, here root 7 minus 5 upon 2 is a conjugate pair, that is root 7 minus 5 upon 2 is a conjugate pair of root 7 plus 5 upon 2. That means those are the conjugate pairs of binomial quadratic surds, and those conjugate pairs are useful to solve the few examples which is based on rationalization of denominator of given surds, and that type of examples are given in the practice set 2.4. Then we will solve few examples from practice set 2.4. Then in question number 1, few examples are given here, that is root 3 into root 7 plus root 3. Then see here, root 3, that is which is multiplied to root 7 plus root 3. Here it is a binomial quadratic surd. Then we can multiply this by root 3 into root 7 plus, here root 3 is multiplied to root 3 also. Then we get root 3 into root 7, that is root 21, plus root 3 into root 3, that is root 9. That means here root 21 plus root 9, that is 3. Or it can be written like this, 3 plus root 21. That are the few examples given in the question number 1 in the practice set 2.4. Then there are few examples which is given in the question number 2, that is rationalize the denominator. And here few examples are given to rationalize the denominator. That is first one, that is 1 upon root 7 plus root 2. Then see here, in this example, denominator is root 7 plus root 2. That is a irrational number which is a surd. Then we have to rationalize that irrational number is converted into rational number by using conjugate pair of root 7 plus root 2. Then all of you have studied that root 7 plus root 2, that is the binomial quadratic surd, and the conjugate pair of that root 7 plus root 2 is, that is root 7 minus root 2 is a conjugate pair of that binomial surd. Therefore, see here, to rationalize that denominator, we have to multiply numerator by conjugate pair of this surd. Therefore, here 1 into root 7 minus root 2 upon, here denominator is root 7 plus root 2, which is also multiplied by root 7 minus root 2. Then see here, conjugate pair of that surd, by which here we have to multiply by that conjugate pair to numerator as well as to denominator. Therefore, here 1 into root 7 minus root 2, that is root 7 minus root 2 upon, here root 7 plus root 2 into root 7 minus root 2. That means here it is like the a plus b into a minus b. Therefore, we get here root 7 square minus root 2 square. Therefore, here we get root 7 minus root 2 upon root 7 square, that is 7, minus root 2 square, that is 2. Therefore, we get here root 7 minus root 2 upon, here 7 minus 2, that is 5. Here denominator is now rational number. That means here 1 upon root 7 plus root 2 is equals to root 7 minus root 2 upon 5. That is same surd which is written in the form of rationalizing denominator. That means here denominator is now rationalized. One more example which is given in this question number 2, that is root 5 plus root 3 upon root 5 minus root 3. Then see here, we have to rationalize only denominator, not the numerator. Therefore, conjugate pair of root 5 minus root 3 is, that is root 5 plus root 3. Therefore, we have to multiply it by conjugate pair, that is root 5 plus root 3 upon, see here, root 5 minus root 3 into root 5 plus root 3. Then see here, root 5 plus root 3 into root 5 plus root 3, that is root 5 plus root 3 bracket square upon, see here, root 5 square minus root 3 square. Then see here, it is like the a plus b bracket square expansion. See here, a plus b bracket square, that is a square plus 2ab plus b square. Like that we can write, see here, root 5 square plus 2 into root 5 into root 3 plus root 3 square upon, see here, root 5 square 5 minus root 3 square 3. Therefore, here we get the, or solving this example, that is root 5 square, that is 5, see here, 5 plus 2 into root 5 into 3, that is 2 into root 15 plus root 3 square 3. Therefore, upon 5 minus 3, that is 2. Therefore, by simplifying this, 5 plus 3, that is 8 plus 2 root 15 upon, see here, upon 2. Then if we have to simplify this, then we can take the common. 8 and 2 are common in this. Therefore, taking common 2 in bracket, from 8 2 is getting common. Therefore, here 4 plus, here also 2 is taken common. Therefore, here root 15 upon, see here, root 15 upon 2. Then in this example we can cancel 2. Therefore, we get 4 plus root 15. And here upon 1 means there is a rationalizing the denominator. Then see here, there are few examples which is given in the practice set 2.5, which is based on the absolute value of real numbers, or it is also known as modulus value of given real number. Then we will solve few examples from practice set 2.5. For this we have to remind few concepts, that is absolute value of real number. Then all of you have studied real number x. It may be any real number. Then there are three possibilities. X may be negative. That means x, it may be negative, or it may be positive, or it may be 0. There are three possibilities. For example, if x is equals to 3, or if x is equals to minus 3, and if x is equals to 0, then absolute value of that x is written like this. Here, see here, that sign is used here, vertical 2 lines, in which that real number is given, which is known as, or read as, absolute value of x, or it is also read as modulus of x. Therefore, we get here, if x is equals to 3, then we get the absolute value of that positive number is positive, as well as if x is negative number, that is modulus of root minus 3, or absolute value of minus 3 is also 3, that is also positive number. or only we can write the 3, that number. And here absolute value of 0, that is 0. Then that type of examples which is given in the practice set 2.5 we have to solve here. Then in question number 1, the few examples are given here, that is find value of, that is here one of the example is given here, that is modulus of 7 into modulus of -4. Then we have to solve this. See here, absolute value of 7 is 7, just 7, into absolute value of -4, that is 4. Therefore, we get 7 into 4, that is 28. Similarly, if we have to solve one more example, that is absolute value of 5 minus 2, then we get absolute value of 3. Therefore, we get the answer, that is 3. Then in question number 2, few more examples are given here, that is see here absolute value of 7 minus 2x is equals to 5. Then we have to solve this. Then see here 7 minus 2x, it is an equation. Here we get 7, absolute value of 7 minus 2x, then we get here plus 5 or 7 minus 2x is equals to minus 5. Therefore, here we have to solve this. 7 minus 2x is equals to 5. Then 7 minus 5 is equals to 2x is taken here, 2x, or 7 plus 5 is equals to 2x. Therefore, here 2x is equals to 7 minus 5, that is 2, or here 7 plus 2x is equals to 7 plus 5, that is 12. Therefore, here we get x is equals to 2 upon 2, or here we get x is equals to 12 upon 2. Therefore, here we get x is equals to 1, or x is equals to 12 upon 2, that is 6. That means we get here 2 values of x. That type of examples are given in the practice set 2.5. Here topic get completed. Then you should solve all practice set from this chapter. Try to solve the examples from problem set 2. Thank you.